Okay, welcome to the Petrophysics lab, and today we're running the experiment on the PERG 200 to measure the permeability. This one is to measure the gas permeability for core samples and also to determine the Klinkenberg effect. So the experiment is simple. We have the gas cylinder connected to our equipment, and the first thing we need to do is to set up our sample. So we get our sample and we measure its length and diameter, similar to the last experiment. Use a caliper, make sure it's 0, then you get the diameter, you record it, then you get the length, and you record it. Once you get these data, put your caliper back, then that sample goes into this rubber container or rubber holder. It has a shape of a cone. It's a very small shape of a cone or coning shape, so you have to be careful. You put it from the wider part on the top and we slide it down right through. Once it's secured, touch it both sides and we'll put it in here. So the same thing here, there is one side that has wider metal compared to the other one that has thinner metal. If you're confused, you can use a caliper. If you can't see it with eye, just do it with eye. So we put the wider part down and we get the thinner one up. This will help us to slide this in. And the same thing here, the wider one up and the thinner one down. Once you let it go easy. So if you need to push, that means you put it in the wrong way. What that means is if I put this upside down, and that will not go in, so I need to push. Or if I put it correctly here, and I put this upside down, also we need some push, so I'm doing it wrong. So make sure it goes slide in easily like this. Once it's slide in, we take the part. Does not necessarily to come all the way here. That's good. Just take it, put it in the base here. Before you put it in the base, you make sure that the O-ring is there. Right? The O-ring is there, no other fluids. So I put this here to prevent any leakage. And after that, we get the top. So you see, this is the inlet. Down here we have the outlet. We put this one in the top of the sample, then that part goes here to secure it. So I hold this and I secure this. There is a screw in there, you may be able to see it. Make sure that the screw goes in this groove. There's a groove here for the screw, so you may look by the side and make sure they get in. So I'm moving right there. Tighten, tighten, tighten. Okay, has to be very tight to prevent and stop any leakage. So this one we use nitrogen gas for, so any compressed air will be fine with it. Well, the good thing about the nitrogen, it's easier for us to determine the viscosity of the nitrogen, which is needed for the calculation. So I tighten it well. That's very tight, I would say. Okay, then we plug the equipment to the electricity already. So you can see we here have two gauges. That first one reads the upstream pressure, and that one reads the gas flow rate. So the upstream pressure predicts how much pressure is going into the sample, and the gas flow predicts how much gas flow out of the sample. Now this is the upstream flow pressure, and the downstream pressure, it's open to the atmosphere, so it's 1 atm or 0 psig. This is for your information to do the calculation. So as you can see here, it says the maximum supply gas pressure is 25 psig. So I come here and we have 3 valves. The main valve for the cylinder, the small valve connects it to the equipment, and the regulator. So first thing is to open the regulator all the way anti-clockwise. Second, we open this valve, the main valve for the gas cylinder, and check how much pressure. So if you can read here, how much pressure does the cylinder has. Must have pressure more than 25 psi. So I think right now it's kind of low, but it has about 200 or 300, right? Then we come here on this side. I see the pressure at the regulator. So this controls how much gas go from the cylinder through the regulator to the small gauge. So I need to move this up all the way to 25. So I will start rotating this regulator in, and at some point it will start to kick in. So here I have 20, this is about 25. All right, and then I will open this to allow the gas to go through the system. Once I'm done with that part, I come back here and start running my experiment. So in this experiment, we need to measure, we need to run multiple measurements. We need at least 4 data points, which means we need to run the experiment at at least four different pressures and measure the flow rate at those 4 pressures. So the first thing to do is to open the regulator, or make sure the regulator is open by taking it all the way anti-clockwise. So I see here, mine is open. So then I open valve 1. After opening valve 1, I rotate this clockwise until I get, let's say we'll start with 2 psi. So start rotating it, and you see here again about 3. I'll control it, and I'll start to go. You can go from low pressure to high pressure or high pressure to low pressure. So I decided to go with first one. So 1.4, I'll take that, I'll stop and wait until it stabilizes. So I see kind of it stabilizes here, so I'll put the pressure is 1.4. The flow rate is about, okay, it dropped now from it's 1.328. So what I would do is I keep my eye at 1.3 and my eye on the flow rate. Once that drops to 1.2, okay, I'll take the last read, so 27. So I got 1.3 pressure and 27 flow rate. Then I'll push it up to a higher pressure. So I got, all right, 3.5. I'll wait. By the time it goes to 3.4, I'll get the reading, but it's not stabilized, so I'll wait a little bit. Okay, now we're kind of developing some stabilization, but that may give me a feeling that there is a leak, so I'll try to tighten this a little more. All right, make sure all the connections are tight, no leaks. All right, so I got 3.2, flow rate's fluctuating, 3.2, 108, 107. Okay, so 3.2, 106. All right, then I'll push it up a little bit. Okay, 4. 4.5, 165, 64. Okay, 4.5, 164. All right, I need 2 more data point at least. So I got 7.2. Okay, now reach some stability. So 7, 292. Okay, it's good. 292, 293, 292. Okay, let's take 1 more data point. Okay, got 8.5, 3, 7, 2. You can see you don't want to exceed this to go red, which is exceed 400. So I'll go a little lower. Okay, so you have 8.9, I got 395. Okay, what I recommend is after that you try to go to get more data point going down. So while I'll go down and collect more data points. So 7.0, another 7.1, I got 291, 292. Then go down. Okay, 6, 5.9, 231, 230. All right, 230 it is. 230, 229. So I'll make it 229. 228. 227. I always like to stabilizers. So 227, 67. So it's fluctuating there. So stabilize it at 227 because 226 made the pressure to drop to 5.8. And collect more data at the 4, at the 3. And once I'm done, I'll open the regulator all the way to deplete all the gas, then close this valve and take off my sample. Same way, out. Go, disconnect this, and the sample to be ready for the next person. And leave it like this. Then make sure to close all the valves at the end of each experiment. So we close this valve, close the main valve, close the small valve, and open the regulator all the way. Okay? And by then we are done with this experiment. Thank you.